This is part 3 of our test 4 review. I'm going to do some of the problems that I skipped in the last video. Let's start with number 11. It says make a scatter plot of the data in the table to the right. So we need to input the data points, press stat, choose edit, and remember you put the x-values in column L1, and my x-values go from 1 to 6. Those are my y values. Alright, now it looks like all of the x values are between negative 10 and 10. All the y values are also between negative 10 and 10. So I think the standard viewing window will suffice. But if you want to actually see the scatter plot, hit second y equals. Select plot 1 and turn it on. And I'm going to press zoom standard. And it looks like we get a pretty good picture of all the data points. The equation of a power function that models the data is what? Is the next question. Well, we've already inputted all the data points. Let's go back to the stat button, scroll over to calculate, and in this one we want the best fit power function. So scroll down to power regression, which is option A. And it does say round to 3 places. So it looks like A is 3.676. And B is 0.504. The equation of a quadratic function that models the data is what? Okay, so we just have to use a different regression. So go back to stat, calculate, but this time choose quadratic regression. And once again, round to 3 places. So negative 0.114 x squared plus 1.817 x plus 2.04. Part D says the equation of a logarithmic function that models the data is what? So again, kind of easy. You've already got the points in there. But this time choose log regression. Natural log regression is the one you want to look at. So 3.466 plus 2.919 natural log x. Let's move on to number, well, we did 12 in the other video. So we can skip that. 13 we also already did. $14 is another calculator exercise. The total personal income for selected years from 1956 to 2001 is given in the table. And we're supposed to model the data with an exponential function. So let's try doing that. X, by the way, is the number of years after 1956. So go back to Stat Edit, and remember the way you delete stuff on this calculator is clear Enter after you highlight the list. X is the number of years after 1956, and my first year is 1956, so that's really 0. And it looks like it goes by tens, up at least for a while. The very last one, though, is 2001. So let me see what X value that corresponds to. 45. So the last point is a little bit of an exception. All right. So the first model we're supposed to use is an exponential function. So we have all the data points in there. Go to Stat, Calculate. And there is an exponential regression choice. And I'll tell you what, I think it would be a good idea if we save this thing because there are a couple of other parts to this problem. So let's go to Variables, Y Variables, Function, Y1. And that way it'll save it as Y1 in our calculator. But 3 places, 443.821 times 1.076 to the xth power. Part B says the country's total personal income in 2006. Well, how many years after 1956 is 2006? It is 50. So the function is already in there. You just have to go to the table and scroll down to 50. So this one is kind of involved. And it says round to 3 decimal places. Part C, the total personal income will reach 22 trillion in what year? So in Part B, they gave us the X value, essentially, which is 50. In Part C, they essentially give us the Y value of 22 trillion. So remember what you're supposed to do. You're supposed to enter the Y value that they give you as Y2. But just be a little bit careful. You don't want to say 22. You actually want to say 22,000 because everything is in billions. And they gave you the 22 in trillions. So convert it to billions by multiplying by 1,000. And I'm going to go ahead and turn off that plot 1. I was doing something with a different problem. But I do want to choose an appropriate viewing window in this problem. And my x's go from 0 to 45. So I think I'm going to change my x max to maybe 100. And my y's go all the way up to 10,000 something. So I'm going to change the y max to maybe 30,000. And I should see 2 graphs. One of them is going to be an exponential function. The other one's going to be a horizontal line, a constant function. So to answer the question, I just have to find the point of intersection. And remember, the way you do that is to go to Calculate, which is right above the trace key. Choose Intersect. And then just press Enter 3 times. The x value of that point is the number of years after 1956. And it does say round up to the nearest year. So it says 52.98. Even if it said 52.1, because it says round up, I would round it up to a 53. So it's a 1956 plus 53. And that's 2009. So a good problem with the calculator. And we did number 15 already on the other video. We'll skip it here. And I believe we also did number 16 on the other video. But let's do number 17. It says graph this function on a window that shows a local min and a local max. So let me delete some of this other stuff we did. Here's the function we're supposed to graph. X cubed plus 4x squared plus 6. And I'm going to start with the standard viewing window. And it looks like we probably want to increase the Y max a little bit. So let's select window. How about if we make Y max maybe 50? That might give us a better picture. By the way, the original function was a cubic function. So the maximum number of turning points I can have is 2. And notice both of them are on there. So that's a pretty good picture. Now let me show you how to find the max and min with this calculator. Remember, I did post a video that shows you how to do it with Inspire as well. I'm going to try to put up some more Inspire videos. But let's find the max point first. So go to second trace, that's calculate. Choose maximum. So remember, you move a little bit to the left of the max point, press enter. Move a little bit to the right of the max point, press enter twice. So it looks like your maximum point to the nearest hundredth is negative 2.67, comma 15.48. And you can find the minimum point by doing something similar. Go to calculate, second trace, choose minimum, but this time move your cursor a little bit to the left of the minimum point, press enter, then move it a little bit to the right of the minimum point, press enter twice. So the minimum occurs, notice that's essentially 0, 6. There's that E negative 6 again. That's essentially a 0. So 0, 6 is your minimum. And I believe number 18 is kind of similar to the one we just did. So I will skip that one. And 19 and 20, those are basically the two problems from section 6.2. I've already given you a video for that.